VLANs. So now we want to do lab 1-2 on VLAN configuration. Virtual local area networks are important because number one, they can be used to isolate different parts of your local area network in order to reduce the number of broadcasts. That is number one, and also for security purposes. So it can also be used to just separate different departments so that they cannot be able maybe to access each other. Like students being able to access the finance department computers. So it's also used in terms of security in one way or another. So in this particular lab, we have these objectives: to assign port interfaces to become access and trunk ports. We already have learned about access and trunk ports. To create VLANs, so you're going to create VLANs. To configure VLAN tagging over ports using the hybrid port link type, and also to configure the default VLAN for an interface using the port VLAN ID. So those are some of the things that we are going to learn here. So this is our our topology. Generally, we have two switches. We have two switches, S1 and S2, and all these other devices here are simply working as end devices. So in my topology on my ENSP, I've actually used PCs. So I've actually used PCs instead of using a switch and those routers, because there's no need to. So I've simply used PCs. I've replaced them with PCs. They're going to play the same role, because we are going to create VLANs on S1 and S2. So those other switches on the router, they're simply working as end devices. Okay, the other thing we are going to do is we are going to create, so this is going to be an Ethernet trunk. So we are going to combine G009 and G0010 so that they function as a logical single pipe between S1 and S2. So that's the other thing that we are going to do. We've already done that in the previous lab, so we're going to do it again. Okay, so let's look at task step 1. So for us, we are starting with an unconfigured device. So we need to begin here and then move to step 2. So generally, we are supposed to create an Ethernet trunk between S1 and S2. They're supposed to work in LSCP mode. Then we add G009 and G0010. So that's the very first thing that we are doing on both S1 and S2. So let's begin there. So let me open S1 and S2. So we begin by renaming. This name S1. This name is 2. Sorry. S2. Okay. So now we want to create an Ethernet trunk. So int trunk1. We specify the mode as LSCP static, like that. Then we go to int G0/0/9. Godfrey, did you raise your hand?
Yes.
Yes, go ahead.
Kindly, may you share your screen so that we can see the configuration ongoing?
Oh, I'm actually sharing my screen.
No, what you are displaying is the lab guide.
Oh, okay. I thought I had shared the entire screen. I'm very sorry. Let me see. Share. Yeah. Okay. Okay. So are you able to see my CLI now?
Yes, I can see it.
Oh, sorry. Thank you for that reminder. Okay, so I think I've already done for this one. Display this. So I've added to Ethernet trunk 1. I also do for G0/0/10. So we are simply creating an Ethernet trunk between S1 and S2. So we also add it to Ethernet trunk 1. So if we do display ETH trunk 1, we can see that they have been added for this particular device. For the partner, not yet, because we've not configured. We've not configured S2. So now let's do S2. So we create interface Ethernet trunk 1. Then we choose the mode as LSCP static. Then we go to interface G0/0/9. We add it to Ethernet trunk 1, like that. Then we go to int G0/0/10. Then we add it again to Ethernet trunk 1. So we will quit and display Ethernet trunk 1. We should be able to see that we've added it. So I think that is it about step 1. So step 2 is disable unused interfaces and establish a VLAN trunk. So we really don't have to do the shutdown, because any interfaces that we've not connected, their state is already down. So we really don't need to do that. So we need to now do this. So the link type of a switch port interface is hybrid by default. In Huawei devices, hybrid. We know how hybrid operate from the theory class. So we want to configure the port link type for the Ethernet trunk 1 to become a trunk port. We know that trunk ports are the ones that interconnect switches, and they carry both tagged and untagged frames. So we want to configure the Ethernet trunk 1 that we just created into a trunk port. So additionally, allow all VLANs to be permitted over the trunk port. To the command to configure it as a trunk port is we have to go into the Ethernet trunk. Then we use the command port link type trunk. Then after that, we can now do port trunk allow pass VLAN all. So these will allow all the tagged frames to pass through the trunk, and the trunk here in our case is an Ethernet trunk. So let's do that both on S1 and S2. Excuse me. So let's begin with S1. So int ETH trunk 1. Then we do the port link type trunk. So if we do question mark, we can see the port types that we have: hybrid, trunk, access, and also we have a .1Q tunnel. So this one is a trunk because it's interconnecting switches. So we specify it as a trunk. Then we go ahead and use the command port trunk allow pass VLAN all. So this will allow all tags from all VLANs, all tagged frames from all VLANs to be carried through this particular trunk. So after we do that, we now go to S2 and do the same thing. So we go into Ethernet trunk 1. Then we change the port type. So port link type trunk. Then we do port trunk allow pass VLAN all. Good. So now we've also done that. Now, before we go to step 3, to configure the VLANs, here we've been told that S3, R1, and R3 and S4 are all non-VLAN aware hosts. So they are not participating in VLAN tagging. So that's why I've just used PCs. So the first thing we need to do is to configure. We want to configure all interfaces associated with the host. They need to be configured as access ports. But even before we do that, we want to also configure IP addresses for those particular devices. So let's just do that. So in PC1, PC1 is supposed to have the IP address 10.0.4.1. So we do exactly that. So here we do 10.0.4.1. Then the mask is 24, so 255. After we are done with that, we simply do apply and close it, and then go to PC2. PC2 is supposed to have 10.0.4.2. And then I'm doing 255. We apply. We go to this guy, 10.0.4. This is PC3, so .3. That's how I've organized them. Just a little different from the topology on the lab guide, but it still should work. 0.4, sorry. It's supposed to be 4.4. So 255.255.255. Okay. So without VLANs, for example, if I go here to the command, without creating VLANs, all of them are in VLAN 1. By default, all switch ports are on VLAN 1. So by now, we should actually, you see PC, we want to configure PC4 to be on VLAN 2, while PC1 to be on VLAN 3 and PC2 and 3 to be on VLAN 4. But before we create the VLANs, PC4 should be able to access PC3. So for example, if we do ping 10.0.4.3, we should be able to get replies. So PC4 should also be able to ping PC1. So ping 10.0.0.4.1. So generally, everyone else can access everyone else. So I hope you've seen that. So now we want to configure VLANs so that we can separate traffic. Okay. I think someone's mic is on. Please mute your mic. Kimutai Johnson. Okay, so let's move on. So on S1, we want to associate the interface that have connected to the end devices, to the PCs. We want to configure them as access ports. Similarly, on S2, the interfaces that have been connected to the PC, we also are supposed to configure them as access ports and also add them to their respective VLANs. So let's do exactly that. So here they have they have specified the port link type before creating the VLANs, and they're creating VLANs one by one. VLAN 2, VLAN 3, so that's one way of doing it. VLAN 4. The other way of doing it, which is a little bit easier, is creating the batch, like what they've done here on VLAN on S2. So you do VLAN batch. That's the easier way. You create them in a batch, then you go to an interface, you change it to an access port, then you add it to a VLAN with this command, port default VLAN this. So this is the method that I'm going to use. I'm not going to use creating one by one and adding a port one by one. So I'm going to use this second method. So let's begin. Here I think we need to be seeing our topology on the background so that it can guide us. Okay, so on S1 we want to create VLAN 4, VLAN 2 all the way to 4. So we use the command VLAN batch 2 to 4. So we've created VLAN 2 to 4. Then we go into this interface that is connecting PC1, G001. So int G0/0/1. Then there we do port link type, access. So we do that. Then port default VLAN. So PC1 is supposed to be in VLAN 3, so we add it to VLAN 3 like that. So that's the command, port default VLAN 3 like that. So if we do display this, we can see that G001, we've configured it to be an access port and it's on VLAN 3. So we do the same for the next port here. We do the same for the next port here, that is, let me clear. So we do the same for G002, which is connecting to PC2. So int G0/0/2. Then we specify the port link type, as access, like that. Then port default VLAN 4. Sorry, VLAN 4. So PC2 is on VLAN 4, as we can see here. PC2 is on VLAN 4, like that. So we can do display this, and we should be able to see that. Okay, so we go ahead now to to switch to. Let me clear this. So we also create a VLAN batch. So VLAN batch 2 to 4. Then we go ahead and add the PC. We add the interface that is connecting PC3. So that is internet interface G0/0/3, as you can see there. So we specify the port link type, as access. Then port default VLAN 4. So PC3 is supposed to be VLAN 4, so we add it there. Then we go to the next interface, G0/0/4, which is connecting PC4. We also specify the port link type as access. Then we do port default VLAN 2. So PC4 is supposed to be on VLAN 2, like that. So now I can quit. So we can use the command display VLAN. We can use the command display VLAN to see all the VLANs. Display VLAN. So you can see the total number of VLANs is 4. So this is VLAN number 1. All ports by default are on VLAN number 1. So we've seen that on VLAN number 2, the Ethernet trunk will be able to carry VLAN number 2 frames as tagged. TG is tagged as tagged frames. We can see that on VLAN number 3 on switch 1, we've added G001. which is connecting PC1, and it's going to carry its untagged link. So it carries untagged frames, and of course also the Ethernet trunk. And on PC1 again, on switch 1 again, we've also added G002 on VLAN 4, on VLAN number 4, and also the Ethernet trunk, which is going to carry tagged frames. So those are the 4 VLANs, and you can also do the same on this guy, just to see that we've configured all the required VLANs. So display VLAN. So I think we've also done the correct thing. So here we are supposed to have VLAN 2. We've added G004, which is PC4. VLAN 3, we've not added any end device on VLAN 3. VLAN 4, we've added G003, which is PC3 here, as you can see. So once we verified this, the ping now, you remember we were able to ping just recently, we were able to ping PC1 from PC4. But now if we try to ping PC1, we cannot be able to ping it because it's on a different VLAN. If we try to ping PC3, we cannot be able to ping PC3. Why? Because it's on a different VLAN. So VLANs can also be used to separate traffic from your local area network subnets. Okay, so I hope you've seen that. So let's look at the next step. So I've already explained this. Configure IP addressing for each VLAN. We've already done this. So verify the configuration by checking the connectivity. So now let's look at who is on the same VLAN. Who is on the same VLAN? So PC4 cannot ping PC3, but PC2 and PC3, because they're on the same VLAN, they should be able to ping each other. So let's demonstrate that. So let's go to the command. So we want to ping PC3. So ping 10.0.4.3. So you see, we are able to ping. We are able to ping PC3 because we are on the same VLAN. But for instance, we cannot ping PC4.4 from PC2 because they are on different VLANs. So that is what we're actually showing there. Okay, so now we want to configure hybrid interfaces. Hybrid. So use the hybrid port link type to allow VLAN tagging to be closely managed at a port interface level. So we shall use hybrid ports to allow tagged frames from VLAN 4 to be received by VLAN 2 and vice versa. So that's the power of hybrid interfaces, in that you can still be able to access PCs from different VLANs can still be able to access each other. So that's what we want to do. So to do that, we set the port link type of the interface G001 of port S1 on switch 1, and the interface 3.6 of S2 as hybrid ports. We want to make VLAN 4 and VLAN 2 to be able to reach each other. Let me just see so that I know the VLAN 2 and 4. So this one and this one. Okay, so these are the particular interfaces that we are going to change to hybrid. 4, 3, and 2 on S1 here. So that's what we're going to do. Okay. So to do that, we have to undo the port default VLAN. That is the VLAN that we had added it to. Then we specify we specify the link type as hybrid. Okay. So let's do that. So on S1, we're going to configure G002. Okay, so let's do that. So S1 int G002, like that. Then we do the command undo port type. Undo port default VLAN, like that. Then we do port, we change the link type, port link type to hybrid. Then we change the port hybrid, so we allow it to carry tagged frames and tagged frames for VLAN 2 and 4. Then we add it to VLAN 4. So how we do that? Port hybrid PVID VLAN 4, because PC2 is on VLAN 4. So we do the same on switch 2. So on switch 2, we are changing G003 and G004 because we want to enable this and this to be able to communicate. PCs on VLAN 2 and VLAN 4. Okay. So we go into int G0/0/3, like that. Then we undo port default VLAN. Then we change the port type, port link type hybrid. Then port hybrid and tagged VLAN 2 and 4. That. Then we add it now to VLAN 4. So VLAN 4 port hybrid or VLAN 4. So after that, we also do for int G0/0/4. So again here we undo the port VLAN default VLAN. Then we do port hybrid port link type hybrid. Then we add that particular port hybrid and tagged VLAN 2 and 4. We want it to be able to allow frames from VLAN 2 and 4, but we add it to VLAN 4. So port hybrid PVID VLAN 4, like that. So generally what we've done on switch 2 is enabling G003 and G004 to be able to receive untagged to untag frames that have a VLAN ID of 2 and 4. Okay. I think there's a. Let me just check. Oh, this one G004 is supposed to be on VLAN 2, and I've added it on VLAN 4. Let me just check. Int G0/0/4. Display this. Let me just change that. Port hybrid. It's supposed to be on VLAN 2. Port hybrid PVID VLAN 2. Okay. Okay. It's supposed to be on VLAN 2. 4 is on VLAN 2. As you can see here, 4 is on VLAN 2. So I'd added it to VLAN 4 by mistake. Okay. So now, once we've done that configuration, we should be able to ping devices that are on VLAN 2 and 4. So the port hybrid PVID VLAN command will ensure frames received from the host are tagged with the appropriate VLAN, a VLAN tag. So frame received from VLAN 2 or 4 will be untagged at the interface before being forwarded to the host. So now, if we ping devices that are on either VLAN, we should be able to reach them. So right now we are on PC2. PC2 is on VLAN 4 here, but we can be able to ping PC4. So let's try that. So you see previously we had pinged PC4 and we were unable to, but because we've configured hybrid, now we should be able to ping it. You see, now we are getting the reply. So that is how hybrid ports work. Okay, so that is it about this particular lab. Thank you very much. Does anyone have a question?